How many Linux users use antivirus software? Update. Just a quick note. This was an answer to a slightly different question. The current question, late 2018, reads, how many Linux users use antivirus software? The answer to that is, very few desktop users use any kind of antivirus or anti-malware software in Linux, but desktop users are a very small share of the Linux install base. A well-built server will employ a number of tools for mitigating malicious activity. Details below explaining both of these points. Linux has a number of tools related to malware and security, but they don't work quite the same as Windows users are used to. I might be telling you things you already know, but let me make the case for the tools we do have, and why most home users don't install or use them. Part 1. Our tools. We have ClamAV, which is more or less a traditional antivirus. It scans files against signatures kept in a database, but it's mainly used to detect Windows, Mac, and mobile viruses. It's especially needed if you're running an email or file server to protect non-Linux users from each other. We have RootHunter, which is used to detect Linux rootkits, as well as poorly configured security. For example, it will warn you if your OpenSSH config is using insecure defaults. Rootkits usually aren't viruses or trojans in Linux, but may be installed by malicious users or during an intentional security breach. There are very few rootkits in the wild, and most of them target relatively old vulnerabilities. So again, this tool is used mainly in server environments where exposure is higher. It doesn't hurt to install and run it on a desktop/laptop machine, but you need to understand how to read the results and act appropriately, or you'll end up doing more harm than good. I recall Hijack this being of similar design and purpose in Windows, way back in the day when I used to remove Windows viruses for a living as an IT technician. We also have a number of intrusion detection systems, log digests, and a programmable firewall, as well as software to manage it. Again, all mostly useful in server environments where some services may present attack surfaces that home users usually don't have to worry about. The LAMP stack is particularly notorious for this. Many popular PHP content management systems and their plugins have permitted remote code execution on poorly configured servers. It's not a terrible idea to install and configure an active firewall manager in Linux just to protect you from denial of service attacks and malicious probing, or as a system-level block list. For example, if you wanted to block all known government IP addresses, or those of the media industry, or those that are known to be controlled by botnets. I'm partial to firewalls and API, depending on distro, but I don't know if there are any GUI tools for managing them, and they're probably not strictly necessary. Unlike in Windows, you don't have a bunch of insecure by default services opening ports left and right on your machine, for which Windows firewalls are a kludgy band-aid. Last but not least, we have SE Linux, which helps lock down software to the files, ports, etc. that it's pre-approved to use, instead of relying on Linux file system permissions alone. Again, this is most useful in server environments, as most home/office users of Linux will find SE Linux difficult to configure correctly. SE Linux can help curb a lot of suspicious and malicious behavior that Linux secure by default design doesn't cover. In this role, it behaves similarly to many popular Windows antivirus suites, but has a very negligible performance impact comparatively. Still, it can be a hassle, and most home-use distros do not activate it by default. Part 1 TLDR. So reviewing the above, we have what you'd expect in a Unix environment, a bunch of very focused and efficient tools that do just one thing, do it well, and play nicely with each other. This is opposed to one monolithic monstrosity that does 9 things you don't need for everything you do, and consumes an enormous amount of system resources to do it as in Windows. Part 2. So do you need any of this? Why or why not? Generally speaking, no, you don't need an antivirus as a Linux home user. There are only a handful of viruses that target the Linux kernel itself. The vulnerabilities they attacked have long since been patched, and to my knowledge there are presently none in the wild. Viruses that attack other system components do exist, but they're usually in the minor annoyance/waste of resources category, not the oh damn, you just got pwned category. For example, aforementioned LAMP stack attacks, the worst of which will infect websites you host with email spamming scripts or permit remote control of a limited subset of your system that Apache has access to. So why don't we have viruses? Every system has holes, and there's no such thing as perfect security, right? Thing is, writing a virus for Linux is incredibly low on the cost-benefit scale compared to targeting Windows, for a number of reasons. 1. The heterogeneous environment. There are almost as many combinations of Linux installations as there are Linux users, so vulnerabilities that exist in one version of one piece of a Linux install is typically limited to a small subset of all Linux users. This can vary a bit depending on environment. As mentioned before, servers have more security concerns than home installs, and popular embedded Linux systems can sometimes lag behind on patches or be frozen at the time of creation. 2. Effective package management, combined with the open source ecosystem. Package managers in Linux almost completely eliminate the possibility of Trojans, because nobody installs software from random untrusted sources in Linux. If you want software, you get it from the distro repo, where it has been reviewed, pre-configured, and pre-compiled for your installation, or if your distro maintainers don't provide it, from a trusted third-party repo. As a very last resort, we may compile something directly from source, but then, at least in theory, the source code is available for review, and we can be reasonably certain that it is not malicious if enough eyes have been on it. Package managers also help to ensure that security patches are installed in a timely fashion, regardless of where the software came from, because there's a central tool to install and update everything. Again, unlike Windows, which until Windows 8's anemic software store had nothing approaching real package management, and arguably still doesn't. 3. It's just better designed. Linux security design is far from a security nuts ideal, but it's pretty resistant to the kinds of exploits that can wreak havoc on Windows. The main example here is that in Linux, we don't let people have root access left and right, or ask for it constantly for trivial reasons. Windows makes privilege escalation a routine one-button click that you're asked to do constantly, and even that, being too onerous for many Windows users, is often the first thing people circumvent. Linux asks very infrequently and only when it's actually necessary, only of users that the sysadmin has specifically granted permission to do so, complains loudly when it's done, and leaves a long audit trail. Part 2 TLDR. It's hard to trick a Linux user into letting software do something malicious. It's hard not to trick a Windows user into doing crazy things to undermine their own security. This is an emergent result of the underlying design. When you make security hard and insecurity easy in the name of being user-friendly, which is nearly a Orwellian term in this context, insecurity should be the expected result.